Here's a brutal truth. You can waste months learning obscure Azure features and still fail the AZ900. The real shortcut is mastering exactly 14 core services. Today, we're breaking down each one, starting with the governance backbone: management groups, subscriptions, and resource groups. The three-layer hierarchy that every Azure resource sits inside. Welcome to Part 1 of the Azure Fundamentals Guide series. Management groups are containers that sit above subscriptions. They let you assign role-based access control and Azure policy once, and those settings cascade down to every subscription underneath. The hierarchy has a root management group at the top. Then, you create additional management groups, nested as needed, with subscriptions attached at any level. A single Microsoft Entra directory can hold all your management groups, giving you centralized governance across your entire organization. Imagine your company has 50 Azure subscriptions, and a new compliance rule demands encryption at rest on all storage accounts. Without management groups, you'd manually apply that policy to every single subscription. Miss one, and you fail an audit. With management groups, you assign the policy once to the parent management group. Because governance cascades by inheritance, every subscription underneath becomes compliant automatically. It's the difference between herding 50 cats and pulling one lever. The most common confusion I see: management groups versus resource groups. They sound similar but solve completely different problems. A management group exists above subscriptions and is about access and policy. Think all subscriptions in the dev management group get the same RBA key roles. A resource group is scoped to a subscription. It groups resources that share a life cycle, like all the VMs and databases for one application that you deploy and delete together. The resource group's location is where its metadata lives, but the resources themselves can be in any region. A subscription is a billing and management container. Each subscription can be billed separately, so you can track costs per environment or department. To create resources in a subscription, you'll need an appropriate role like contributor or owner. Subscriptions are tied to a Microsoft Entra tenant for identity, and they sit under management groups to inherit governance. A classic pattern: 3 subscriptions, dev, test, prod, all under one management group, each billed separately and isolated from each other. 3 concrete benefits of using multiple subscriptions. First, billing. Each subscription gets its own invoice, so you can easily track costs by department. Second, isolation. A runaway script in dev can't crash your production database. Third, policies. You can enforce a policy in test that only allows small, cheap VM sizes, while production keeps full flexibility. Subscriptions give you separation from the ground up. A resource group is a container where you place resources that share the same lifecycle. The resource group's location, here West US, is where its metadata is stored, but the resources inside can live in any region. In this example, a web app VM runs in East US, the database sits in West US, and the blob storage is in Central US. They're created together for a single application, and when the application is retired, you delete the entire resource group and everything inside is removed cleanly. But here's the part: almost everyone gets wrong. You spin up a quick test VM to try a new script, and you drop it into the same resource group as your production database. 2 weeks later, you delete the VM. And because you deleted the resource group, the production database vanishes with it. That's a resume-generating event. The rule: resources that are created, updated, or deleted at different times belong in different resource groups. Group by application and lifecycle, never by resource type. Pause. If someone asked you to draw the Azure governance hierarchy right now, could you? The answer, from top to bottom: root management group, then management groups, then subscriptions, then resource groups, and finally individual resources. Each layer inherits governance from above. If that didn't come easily, rewatch the last few scenes. This hierarchy is foundational. An Azure virtual network is your private, isolated network in the cloud. You define a custom IP address space, typically using private ranges from RFC 1918. For example, 10.11/0/16. Inside that VNet, you carve out subnets, each a smaller block of the address space, like 10.1.1.24 for web servers, 10.1.2.0.24 for application servers, and 10.1.3.U.24 for databases. Resources in different subnets can communicate securely by default, and you can lock things down with network security groups attached to each subnet. This is the foundation every other networking feature builds on. A subnet on its own is open to all traffic by default. That's like leaving every door unlocked. Network security groups, NSGs, are simple stateful firewalls that let you write allow-deny rules based on source IP, port, and protocol. This is microsegmentation. You lock down each tier. A classic three-tier app uses separate NSGs, so the web subnet only accepts HTTP. The application subnet only accepts traffic from the web tier, and the database subnet only accepts connections from the application layer. The most common beginner mistake is assuming a subnet is inherently private. It isn't. Always attach an NSG to every subnet, even if you start with a single deny-all rule. VNet peering gives you a direct, low-latency connection between two virtual networks. No gateway, no internet hops. It works across regions, and traffic stays on the Microsoft backbone. For hybrid setups, you have two main paths. A VPN gateway encrypts traffic over the public internet using IPsec-IC, affordable but at the mercy of internet latency. ExpressRoute is a dedicated private fiber that bypasses the internet entirely, with BGP routing to Microsoft's edge routers. In a real design, you often combine peering for Azure to Azure and ExpressRoute for on-premises into a hub VNet. Open a terminal and paste that first command. It spins up a fully functional VNet with one subnet. The address prefix is the private IP block. It must be from the RFC 1918 ranges like 10.0.0, Zorisol 8. Then, the second command creates an NSG rule to allow only HTTP traffic. Remember, an NSG rule doesn't take effect until you associate the NSG with a subnet. You do that with AZI Network VNet Subnet Update. The CLI is often faster than clicking through the portal, and you can script the whole environment in seconds. In the portal, search for virtual networks and hit Create. Give it a name, pick a region, and then the address space. This is the CIDR block that defines your private IP range, so stick to 10.172.16 or 192.168. The default subnet is already there. You can edit it or add your own. Click Review plus Create, and Azure validates your settings in seconds. The portal is great for one-off labs, but for production, you'll want to export the ARM template or use the CLI. Virtual WAN abstracts away complex networking and gives you a single operational pane. Under the hood, it's a hub and spoke. Each Azure region becomes a hub, and in a standard deployment, all hubs are fully meshed across the Microsoft backbone. That means a branch in Singapore can reach a VNet in West Europe without you building a single VPN mesh yourself. You get branch connectivity via SD-WAN or VPN CPE, site-to-site VPN, point-to-site user VPN, and ExpressRoute, all managed from one interface. The real power of virtual WAN is consolidation. You no longer manage 4 separate connectivity products. On one dashboard, you can connect branch offices using your existing SD-WAN or VPN CPE, set up site-to-site tunnels to Azure, give remote users a point-to-site VPN, and terminate ExpressRoute circuits, all feeding into the same transit network. If you're designing a globally distributed footprint, start here instead of stringing individual VPN gateways together. ExpressRoute gives you a dedicated private tunnel into Azure that never crosses the public internet. Your on-prem edge hands off the connection to a Microsoft Enterprise Edge Router, MSEE, via BGP. Every circuit includes a redundant pair of BGP sessions, so hardware failover is built in. Bandwidth scales from tens of Mbps all the way to multi-GBPs, and with ExpressRoute Direct you can provision even higher speeds for data center scale workloads. The result? Enterprise-grade reliability, consistent latency, and a clean compliance story because your data never sees the open internet. Think of VPN gateway as taking the public highway, encrypted, but still sharing the road with everyone else. Express route is your own private lane. That SLAs directly on express route, no congestion spikes. If you're moving large data sets, meeting compliance requirements, or needing predictable jitter, the private fiber wins. But if you're a small dev shop just learning Azure, a VPN gateway at a fraction of the cost will do fine. Many enterprises use both. VPN as a failover backup to express route. A private endpoint gives your PaaS service its own private IP inside your virtual network. The VM reaches the storage account at 10.1.3.5, not a public FQDN. All traffic flows through Azure Private Link. It never touches the public internet, so there's no public exposure surface. Crucially, connections are initiated outbound from your VNet. The PaaS service cannot reach into your network. This is the default for secure architectures now. Every storage, SQL, and Cosmos DB instance should be locked behind a private endpoint. Too many people spin up a storage account and leave the public endpoint wide open, thinking a SAS token is enough. It isn't. The fix is 2 clicks. Enable a private endpoint so the storage is only reachable from your VNet, then flip Allow Blob Public Access to Disabled. This stops any connection that didn't originate from inside your network. One more thing. Service providers can never initiate connections into your VNet via private link, so you're not opening a backdoor. After you create a private endpoint, all traffic to your storage account stays inside the Azure backbone. The key switch is Group ID, which tells Azure which sub-resource, like blob, file, or queue, you want to lock down. Once this endpoint is live, you can disable public access and still use the service from your VNet. Quick recall. Which Azure service gives you a dedicated private connection into Azure that never crosses the public internet? An Azure virtual machine gives you raw control. You choose the OS, you patch it, you configure updates, and you decide how to scale. Physically, a VM is a combination of an OS disk, optional data disks for persistent storage, and a virtual network interface that plugs into a subnet inside your VNet. VM sizes are organized into families, each tuned for a different job. D-series are the balanced all-rounders. F-series crank up the CPU per memory ratio. E-series pack huge amounts of RAM for databases. L-series deliver extreme local SSD throughput for low latency storage, and N-series add GPUs for AI or graphics. Matching the right family to your workload is one of the fastest ways to keep your cloud bill in check. Availability zones are physically separate data centers inside an Azure region, each with its own power, cooling, and networking. When you place VMs inside a scale set that spans zones, Azure keeps the desired instance count evenly spread across zones automatically. If one zone fails, the others keep serving, helping you achieve the highest availability SLA Azure offers for virtual machines. Check the current Azure SLA documentation for the exact uptime percentage, as it varies by configuration. To build the reflex, next time you create a VM, immediately add it to a scale set with a minimum of 2 instances and enable zone balancing. Here's the part almost everyone gets wrong. Deploying just one virtual machine is still the #1 cause of application outages. Many beginners skip redundancy, thinking it's overkill for dev or test. But that habit follows you into production. At a bare minimum, use a scale set with at least 2 instances, each in a different availability zone. Even your practice environment should wire this reflex. Make it a rule. Never leave a single VM in production. Always enable zone redundancy from day one. Let's make resilience real with 2 drop-in commands. Open your terminal or Azure Cloud Shell and run these. This creates prod VM1 in Zone 1 and prod VM2 in Zone 2, identical except for the JustMore zone flag. A single flag sets the zone, and now you have a simple multi-zone deployment that survives a data center outage. In production, you'd use a scale set, but the pattern is the same. Try it now. Execute the first command to spawn your own zone-specific VM. Azure App Service is a fully managed platform. You hand over code, and Azure handles the servers, the operating system, and the scaling. It runs your app on Windows or Linux, supports popular languages like .NET, Java, Node.js, Python, and PHP, and can automatically increase capacity when traffic spikes, all without you ever touching a VM. Deploy a test app in seconds. Run as web app up. Name. Runtime, Node 18 LTAES. The platform replaces the entire VM management layer with a code-first workflow. Developers flock to App Service because it wraps these 5 capabilities into a single platform. On top of that, it supports Java, PHP, and Go alongside the core stacks. So you rarely have to change your favorite language to get the benefits of POS. The built-in authentication with Microsoft Entra ID, Google, Facebook, and Twitter login saves you days of integration work. Pro tip, always enable deployment slots during creation. They let you swap staging and production with zero downtime. The biggest over-provisioning mistake is spinning up a virtual machine for a simple website. If you don't need OS-level access, App Service is almost always the right call. It dramatically reduces management overhead and pushes you toward a code-first workflow. Reserve VMs for workloads that demand custom drivers, a specific OS version, or legacy applications that can't be lifted into a PaaS model. Action item. Audit your current deployments. If you have a simple web app on a VM, migrate it using App Service Migration Assistant. Let's create a real web app inside the Azure portal so you see exactly how it works. Click Create a Resource and search for Web App. Give your app a globally unique name, then choose the Node 18 LTS runtime on Linux. The App Service plan decides your compute. Pick the B1 Basic tier for low-risk dev testing. Finally, flip over to the Deployment tab and authorize GitHub to automatically deploy your code every time you push. In under 2 minutes, you'll have a fully managed web app that can auto-scale with zero server maintenance. Azure Functions is serverless compute. You write code that runs only in response to events, and Azure handles everything else. No VMs to patch, no scaling to configure. Here's a concrete flow. An HTTP request triggers the function. A blob input binding pulls in a watermark image. The function processes it, and an output binding writes the final result to Cosmos DB. Functions supports CORS, JavaScript, Python, PowerShell, and Go, so you can use the language you already know. Functions gives you 2 hosting plans, and picking the wrong one can hurt performance or cost. Consumption is like a pay-per-trip taxi. You pay nothing when idle, but the first request might hit a cold start. The catch? It kills your function after 10 minutes. Premium keeps instances warm all the time, like a reserved car service, so no cold starts, and you can run functions for as long as you need. Use consumption for low-traffic APIs. Choose Premium for latency-sensitive, production-grade apps that need VNet access. Check the Azure Functions pricing page for exact rates per million executions and per second. Here's a trap that trips up beginners. The consumption plan has a hard timeout of 10 minutes. If you try to run a 30-minute batch job, it will fail with a timeout error. The solution isn't to hack around the limit. Instead, reach for durable functions which can pause and resume across multiple function calls, or use logic apps designed from the ground up for long-running integrations. Test this yourself. Create a simple HTTP-triggered function that runs a loop for 15 minutes, watch the timeout, then rewrite it as a durable function to see the difference. To spin up a function app from the command line, use this single command. The star of the show is consumption plan location. This flag tells Azure to use the consumption plan, so you only pay when your function actually runs. You also hook it to a storage account for triggers and state, and set the runtime to Python, Node, or whatever you need. Once deployed, list your apps to confirm. In one command, your serverless backend is live. Try it now. Run the create command in your own subscription and then call the default HTTP trigger endpoint. Logic Apps is a low-code platform with over 1,400 connectors, turning complex integrations into visual drag-and-drop workflows. Picture this: A sales order email lands in a shared mailbox. The Logic app detects it, immediately creates a corresponding record in SharePoint, and then fires off a notification to the sales team in Microsoft Teams, all without a single line of custom code. Logic Apps comes in 2 flavors, and your choice affects billing, security, and development. Consumption is multi-tenant and charges only when your workflow runs, perfect for simple, low-volume integrations. Standard, on the other hand, runs on a dedicated instance that offers consistent pricing, VNet integration, and even local debugging. For an enterprise that needs isolation, Standard is the way to go. Here's a concrete workflow you can build in minutes. A partner drops a file into an Azure Blob container called Incoming. A Logic app fires immediately, notices the new blob, and copies it over to a processed container for archival. No manual intervention, no cron job to write, just a 2-step visual flow that runs on the cloud. Let's lock in what we've covered. If you need a web API that auto-scales without touching servers, pick App Service. For a tiny piece of code that runs only when a blob lands, use Azure Functions. And when you have a multi-step business process that touches SharePoint, email, and Teams, Logic Apps is your answer. Get those mental models right, and you'll ace the exam in the real world. An Azure storage account gives your data a unique HTTP/HTTPS namespace, and it holds 4 distinct services. Blob containers store unstructured data like images or logs. File shares provide SMB/NFS mounts for lift and shift scenarios. Queues enable asynchronous messaging between app components, and tables offer a NoSQL key value store. Together, they form the durable, scalable foundation for almost any cloud workload. Once you've decided to use Azure storage, you pick an account type. The one-size-fits-most choice is Standard General Purpose V2. It's the cheapest, supports all data services, and is feature-rich enough for nearly every general workload. For performance-sensitive situations, you switch to premium tiers. Block blobs for low-latency transactional apps. File shares when you need enterprise SMB performance, and page blobs that underpin the fastest managed disks. The decision boils down to cost versus per millisecond performance needs. Azure protects your data by silently making copies. Locally, redundant storage, LRS, keeps 3 copies inside a single data center at the lowest cost. Zone redundant storage, ZRS, spreads 3 copies across 3 availability zones in the same region, adding resilience against data center failures. Geo-redundant storage, GRS, copies your data to a secondary region, maintaining 6 replicas total for the highest protection. The cost roughly doubles from LRS to GRS, but for compliance workloads, that extra fraction of a % of durability is non-negotiable. Azure Blob Storage uses 3 access tiers to balance cost and speed. Hot is for data you touch daily. Cheap reads, but higher storage fees. Cool sits in the middle. Infrequent access, 30-day minimum, and no retrieval penalty. Archive is a deep freeze for long-term retention. Storage is dirt cheap, but getting your data back can take hours and may incur extra charges. The classic trap. A team puts actively used log files in archive to save money, then panics when an audit needs those files immediately. And the bill arrives with unexpected retrieval costs. When you script your infrastructure, the Azure CLI gives you precise control. This single command spins up a standard V2 storage account with LRS redundancy and the hot access tier. The critical flag is access tier, which stamps the default tier on every blob that lands here. Choosing hot here means your blobs start at the readiest, most expensive tier. You can later move individual blobs to cool or archive using lifecycle management without retyping the whole account. Azure Key Vault protects your secrets, keys, and certificates using hardware security modules, HSMs, without you ever having to manage dedicated hardware. Instead of storing passwords in plain text, your application asks Key Vault for them at runtime, using a simple SDK call or a special app service reference like Microsoft.KeyVault. That way, the secret never touches the developer's machine or the source repo. The vault handles key rotation and compliance logging, so your team can stop mailing each other .env files. Key Vault comes in two flavors. Standard encrypts keys in software, fine for typical enterprise applications. When a regulator demands the highest bar, Premium uses a dedicated hardware security module that keeps keys in tamper-resistant hardware, offering stronger compliance assurances. If your project handles credit card data, health records, or government secrets, Premium is the tier you'll budget for. But here's the part almost everyone gets wrong: hard-coding a database password or API key right in the source file. A single Git push, and that secret lives forever in the repo history, discoverable by anyone who clones it. The correct pattern is to use a Key Vault reference. In App Service, it looks like a Microsoft.KeyVault, secret URI, or HTTPS, RCS, yourvault.vault.azure.net, secrets, connection string. At runtime, Azure swaps that reference for the actual secret without ever writing it to disk. This simple refactor prevents credential leaks that can cost a company millions. Azure Monitor is the single pane of glass for everything happening in your cloud. VMs, containers, and application code stream telemetry into two separate data platforms. The Log Analytics workspace stores verbose logs and distributed traces, queryable with Kusto Query Language, KQL, while the Azure Monitor workspace handles high cardinality metrics served via PromQL. Application Insights plugs into your app to capture performance traces. From there, you build alert rules that can auto-scale your fleet, and dashboards that give your team an at-a-glance health check. Azure Monitor's skill set goes way beyond just logging errors. Application Insights traces every HTTP call, so you know if the checkout page gets slow. Smart Alerts use machine learning to spot unusual patterns and fire only when something truly abnormal happens. Autoscale hooks directly into those metrics, keeping your app responsive at 4 a.m. during a traffic spike. Custom dashboards and workbooks let you tell the health story of your system, all queried with KQL, a language you'll use everywhere in Azure. Before you go, quick quiz. What redundancy option protects against a regional outage? That's geo-redundant storage. It replicates your data to a secondary region. And just as important, what query language do you use to dig into Azure Monitor logs? KQL. In the next part of this Azure Fundamentals series, we'll explore Azure databases and advanced security. Hit subscribe so you don't miss it. This is where your cloud journey gets hands-on.